Hello, hello. Hello, guys. I'm Mr. Armstrong, and I'm going to be going through some algorithms questions. This is an assessment that I did in my class a few weeks ago, and I thought it would be useful to go through all the answers for anyone who is struggling with the algorithms in AQA Computer Science A-level. So we'll start, and we're going to start with a question on recursion. Now, if there's a question on recursion in your exam, this is pretty much guaranteed going to be one of the first questions they're going to ask you. You need to know how recursion works, and this is a question we're going to do. Okay, this is one that they're going to ask, and we're going to go through it. I'm going to do it using an example, and we're going to create our own recursive routine as it goes along. Okay, in my example, it's going to be using triangle numbers. Okay, so let me explain how these work. Here, I'm going to say our first triangle number, our second triangle number, third and fourth triangle number. And a triangle number is basically how many dots does it take to make a triangle. Okay, well, the first triangle number, I can make a triangle with one dot. And easily enough, how many dots are there? One. Okay, the second triangle number, well, I can have a dot. But then how do I make a triangle out of this? Well, I add two dots underneath, and here we are. Here's another triangle. How many dots is that? Well, it's 1 plus 2. The third triangle number, well, I can take this triangle, then I can add 3 underneath, and that's still a triangle. How many dots are there? Well, 1 plus 2 plus 3. So that'll be 6, right? And then this will be 3. And then finally, let's continue with the example. Got 1, 2, 3, 4. Okay, so like this. So let me change the color up now. The idea is, here's my triangle. Okay, and to make the fourth triangle number, hopefully you can see that within the fourth triangle number, there's a third triangle, right? So I've added 4 to the number of dots in here. Okay, number of dots in the previous triangle. And hopefully, because you can see that there it is, right? And here I can see, to make the third triangular number, I take 3, right? 3 dots plus the number of dots in the previous triangle. Okay, and then finally, well, not quite there yet, but then we have 2, right? 2 dots plus the number of dots in the previous triangle. Okay, and then what happens at 1? Well, we stop. We don't go any further than this. Okay, so let's make a recursive function for that. Okay, this function is going to return the number of dots in a triangle. So we're going to say triangle, and we're going to say what triangle number is it, right? So let's say if you want the fourth triangular number, we'd do this, right? Let me add a little bit of bonus detail here. It's going to be an integer. Okay, and it's a number. This is our parameter. Okay, what is our function going to do? Well, what did I just say? How we created this triangle? What do? Well, we take 4, for example, or we take the position is 4, and we add it to the number of dots in the previous triangle. So I'm literally going to say where we're at. So let's say I've plugged in 4 here. This will then be return 4 plus the number of dots in, well, we're going to call this function again because, oh, how do I know how many dots I have in a triangle? Well, luckily, I've got a function that gives me it, and this is what we're doing. Here's our function that gives us it, and we want the previous triangle, right? So we're going to do num minus 1. And suddenly, we're then doing triangle 3. Okay, that's the idea. And I'm going to do that in a moment. So let's kind of go over here and kind of explain what's happening. So it's going to be 4 plus triangle 3. Okay, that's what we've done. What's triangle 3? Well, triangle 3 is then going to become 3 plus triangle 2. What's triangle 2? Well, it's going to be 2 plus how many dots are in the first triangle. And then what did I say what happens here? Well, we can't go any further back than this triangle. Right, so we've got to stop somewhere. This is going to be our stopping condition because there's no previous triangle, so we've got to stop somewhere. So we just don't go on forever. I'm going to say this. If num is 1, what are we going to do? We're just going to return how many dots are in that triangle. And we know that in the first triangle, there's going to be 1 dot. That's it, right? So then triangle 1 is then going to become 1 here. And then finally, as you can see, it's become 4 plus, sorry about that, we're going to add 4 plus 3 plus 2 plus 1. Okay, so that'll be 4 plus 3 plus 2 plus 1. Right, and that gives us exactly what we want, which is going to be 10. We've created a recursive routine to calculate how many dots are in a triangle. What have we done? Well, a recursive routine, it calls itself. You can kind of see here, right, that we've got triangle here. It needs to call itself. What else needs to happen? Well, when we got back to a 1, we're not just going to go on forever, right? We need to we've got to stop somewhere. So it needs to have a stopping condition. Okay, it needs to have a stopping condition and needs to have an opportunity to finish. Okay, and then finally, which is kind of the one that most students forget, is we actually need to get somewhere. We need to be making progress. So if I did this again, but I didn't have a minus 1 here, what was going to happen? Right, well, it's going to be 4 plus, I'm just going to do triangle for short just to save me space, right? But I can do 4 plus triangle 4, right? Because I haven't changed the number. So what's that going to become? Well, that's going to become 4 plus triangle 4. Okay, so we're going to keep calling it again. We're going to go again. What does 4 equal? Well, that is 4 plus triangle 4. And you can kind of see that we're not making any progress. This is going to go on for infinity. Okay, so we need to actually get to the stopping condition. So that's the next thing. Get to the stopping condition in a finite number of steps. That's the 3 things that recursive routines need to have in a finite number of steps. These are the 3 things that you need to know for a recursive routine. Okay, let me just get rid of this because that's not what you should be remembering. It should be num minus 1. Okay, so fantastic. That's step 1. Question 2 is now going to be like this, and we're just going to use these rules that we now know to calculate it. Okay, so what did I say the rules were? Rules were they need to have they need to call themselves. Okay, so to call itself, that's what a recursive routine. Here's add numbers. Does it call itself? Yes, we've got one here. Print numbers. Does print numbers call itself? Yes. Does numbers call itself? Yes. What was the next rule? It needs to have a stopping condition. It needs to have a moment where it's like, oh, I can't go any further than this. Okay, I've got an if statement where I can't go any further than 1. Okay, sorry, I've got this if statement, and then it means that if we're greater than 1, call itself. Otherwise, we have this moment where we're not going to call itself and we can finish. Right, so this is a stopping condition. It's got this condition here that says, past a certain point, we're going to just end and we're not going to call ourselves. So that's got a stopping condition. Does this one have a check? There's no check here, right? It's no if num is greater than 2 or whatever, right? It's just going to go, it's just going to return, it's going to do it forever and ever and ever and ever and ever. So if I put 4 in here, it's going to be, be num3, and then we're going to call again and put 2 and then 1 and then 0 and -1 and -2 and -3. There's no checks to tell us when to stop. So this guy isn't going to do it for us. Okay, this guy isn't going to do it for us. So this is a big no. Does this guy have the stopping condition? Yes, it's an if statement. Finally, we need to get to the stopping condition. Are we going to do it in a finite number of steps? Well, are we progressively going towards something? Are we going to get towards our stopping condition? Well, yeah, right. We're happy if we're greater than 1. We're happy, right? So let's put 4. Well, it's going to go 3, 2, because I've got a 4, and then num -1 becomes 3, then 2, and then 1, and then we're progressing towards our target, our stopping condition. So this guy has all 3. So this guy is the big yes. There's no point even checking number 2 because we know it's not. Finally, does this guy progress in any way towards the stopping condition? Hopefully you can see that there's no progression. If I put in 4 here, we're going to have numbers. We're going to have numbers 4 -1. Then what's this going to be? Well, this is going to become numbers 4 -1. What's that going to become? Oh, that's going to become numbers 4, because this number is not changing, because we're plugging it in every time. Every time we plug it in, we're going to plug in 4. There's no difference. So this guy is no. So your answers to this question are going to be here. This guy, only the first one, because it meets all of these conditions that we've created here. We're going to continue with this question now. So let's have a look. The following pseudocode subroutine merges 2 sorted lists of equal or unequal lengths. Okay, fantastic. It's merging 2 sorted lists. Does that sound familiar? It should do, because we've got a merge sort happening. Okay, so long story short, with a merge sort, is we're just going to be comparing 2 lists and putting them one in front of each other. So let's just do one really quick list. All right, here's my really quick list, and then we can do an example here. With what merge sort does is it breaks up into individual components, and then I realized I've picked one that's already sorted. Hold on, let's try that again. That's actually not sorted. Try that again. 11, 1, 4, 7. Let's try that one. Get it the right way around this time. So what a merge sort does is it breaks all the numbers up into individual components, and then slowly but surely does this merging technique, right? So this is a little list, this is a little list. Oh, it combines these two and says, oh, who should be in front of here? It should be 1, and then it should be 11. Are these in the right order? I'm going to compare 4 and 7, and then we do this. Right, and then so we just keep on merging. And what we do is we compare the first element every time. Okay, so 1 and 4, so 1 goes first, and now 1's not there anymore. So it's like this, and it's 4 and 11. Surely then that'll be 4. So now you're not there anymore, and we've got 11 and 7, so we put 7, you're not there anymore, and then 11 will go in. So that's kind of how merge sort works. Okay, just a very quick outline. So let's read this question. What will be printed when the statement print merge list at line 23 is executed? What is that doing? Well, this is printing this variable merge list. What does merge list contain? Oh, it contains these two sublists, list 1 and list 2, merged together. That's nice and easy, because I've just shown you that merge list combines these two lists together. So let's do the example again. We had 3, 7, 9, and 1, 2, 5, and 10. So here we are now combining these. We're going to compare 1 and 3 and get 1, and then you're going to go and going to compare 2 and 3, right? And then 2 is going to go. We're then going to compare 3 and 5, and we're like, oh well, 3 goes. So what's happening? Obviously, it's a sorting algorithm. It's going to sort the lists. It's going to sort them. So it's literally 1, 2, 3, 5, 7, 9, 10. You can leave it as brackets and commas or whatever, all they want. The important thing is you realize that these are the numbers. Okay. So next thing, give the statement of recursive calls in the subroutine of recursive call is when a program calls itself like we just did. The routine is called merge. So we're just looking for merges. No merge, no merge, no merge. Oh, there's one. Line 12. And then is there any other ones? Oh, yes. Line 15. So 12 and 15. Okay. So this is fantastic. We're getting through. That's a really easy 3 marks we got here. What parameters will be passed to the subroutine the first, second, and third time that the recursive call is made? So it's important that you know how merge sort works, given my examples, right? And I was just given the general example, but they might subtly change the algorithm in the exam, and therefore it's really important to just kind of read the code and understand what's happening. Okay, because they might be subtly different. Okay, so we're not just gonna willy-nilly do our merge sort. We're gonna follow the routine because there might be something slightly different. Okay, that's what we're gonna do. So let's make this happen. So I've just cleared all the drawings so you guys can see it a bit better. What parameters we pass into subroutine first, second, third times the recursive call is made? Well, first thing we should do is kind of keep track of what we're starting with, and then we can kind of work our way through. Okay, so let's start with this. Initially, our list is a bit like this. Okay, so list 1 and list 2 are 379 and 1, 2, 5, 10. Okay. So let's crack on. So we've got list 1, list 2. These are the lists we've got in. Are these lists zero length in any way? No, never a zero length, never a zero length, never a zero length. So what's going to happen? We're going to be comparing the first element of list 1. So remember, it goes 0, 1, 2 for indices and 0, 1, 2, 3 for indices. So we're going to be comparing the first element and the second element. Okay, is 3 less than 1? No. So we then go to the next thing. Is the first element of list 2 less than the first element of list 1? Yeah, so this is where we're at. What we're going to do is we're going to return list 2, and then we're going to merge this. So what it's asking for is, what are the parameters? What are the parameters of when we call merge? Well, the parameters are going to be the entirety of list 1. So this is the entirety of list 1. So let's write it up here so we're kind of next to the code, right? And then what do they want? Well, what does this symbol mean? Well, they've told us, right? It's a list, but you just get rid of the first element. Oh, wow. Okay. Well, then that just becomes 2, 5, 10. And now that's what we've called. That's the first call. And now we can start back again up here, but these are now our lists that we've got. Okay, so same thing again. Are the lists 0 in any way? No. So are the length 0 in any way? No. So skip that, skip that, skip that, and then we can check, is the first element of the first list less than the second list? Nope. Right, so we're going to go to here again. Is the first element of the second list less than the first list? Yep. Right, so what we're going to do is now this. We add the first element of list 2, and then these are our new parameters. It's going to be the entirety of list 1. Nothing's happening to it. And then it's going to be the first element of list 2. Sorry, it's going to be list 2, but you get rid of the first element. So 5, 10. And now we've called it, so we're back up here again. Skip your way through. It's the first element of our new list 1 less than list 2? Oh, yes, it is. So what we're going to do, so we're now here, right? Is the first element of list 1 less than list 2? Yes, it is. So this is our new line that we're doing. Okay, so we want list 1, but without the first element, and then the entirety of list 2. And that is that question done. So what you would put is this, this, and this, but down here.